Alright, so our fourth video on finding absolute extrema. Well, first let's look at what we've got to do to find them. Okay, so to find the extrema of a continuous function f on a closed interval ab, we use these steps. We find the critical numbers of f and ab. And then we take the critical numbers and we evaluate f at each of those critical numbers. Okay, now make sure the critical numbers are in the interval ab. And then we evaluate the function at each endpoint. Okay? And then the least of these values is the minimum, and the greatest is the maximum. So let's see what we've got. Alright, so find the critical numbers. So first thing we do, we find the critical numbers, so we take the first derivative. So that's going to be 2 cosine x. And then the derivative of cosine is negative sine, so that's going to be plus the sine of 2x times the derivative of what we're taking the cosine of, which is 2. And so I've got f prime of x is 2 cosine x plus 2 sine 2x. Okay. Alright, so now we need to set this equal to 0. So I've got 2 cosine x plus 2 sine 2x equals 0. So to solve this, well, we got to do something with this. So hopefully you remember your double angle identities. So that's going to be 2 cosine x plus, there's that 2. And then remember, sine 2x is what? 2 sine x cosine x equals 0. And so this is going to give me 2 cosine x plus 4 sine x cosine x equals 0. Well, I'll factor out a 2 cosine, so 2 cosine x times 1 plus 2 sine x equals 0. So that gives me cosine x equals 0, or 1 plus 2 sine x equals 0. Now, notice I didn't write the 2 here. I mean, if you had 2 cosine x equals 0, if you divide by 2, you should get cosine x equals 0, so you don't need to write the 2 down. Alright, so for here, cosine x, that's what? Where's cosine 0? It's 0 at pi over 2 and 3 pi over 2. Remember this, here's the graph of cosine. There's 2 pi, pi over 2, 3 pi over 2, and pi over 2. There's 1, negative 1. And remember, cosine looks like this, and see it's 0 here at pi over 2 and 3 pi over 2. Alright, now this one, well, let's get sine by itself. So I get sine x equals negative 1/2. So in this problem, I know that my solutions are going to be in the third and fourth quadrant because that's where sine's negative. Alright, so hopefully you still remember how to solve trig functions. Alright, so to find our third and fourth quadrant angles, we need the reference angle first. So I've got sine in my reference angle. Remember, that's going to equal a positive 1/2. And so for my reference angle, sine is 1/2 at what? 30 degrees, so that's pi over 6. So there's my reference angle. So if I draw my solution in the third quadrant, remember this is pi over 6, my reference angle. There's my angle. So in this case, x would be pi plus pi over 6, which is 7 pi over 6. And so one solution is x is 7 pi over 6. And then the other solution, I'm going to erase this. Okay, so is in the fourth quadrant. There's x. Here's my reference angle, pi over 6. And so x would be 2 pi minus pi over 6, which that would be 11 pi over 6. And so I've got 11 pi over 6. All right, so we've got quite a few here, so I need to take these values and these values, plug them back into my original, and I've got to plug the endpoints in as well. All right, so I'm gonna erase all this stuff up here and rewrite my solutions up here so we're not way down here, because we need to get back up to the original function so we can plug all this in. I'm going to pause the video while I do it, and when I start it back I'll have everything written up there. Alright, so here we go. So here's my critical numbers. So I have to take each one of these, plug them back into the original function. So let's look at this. We've got f of pi over 2, which that is 2 sine pi over 2 minus cosine of 2 times pi over 2. So let's see what that gives us. Well, the sine of pi over 2 is 1. Okay, so that would be 1. And then the 2's cancel, so I've got the cosine of pi, which is -1. And so when I punch all of that in, the pi over 2, I end up with, well, that would be 2 minus a -1, so that would be 3. Now let's do the 3 pi over 2. So 3 pi over 2. And it's going to be similar to this one. I'm not going to show you all the work. You should know how to do that. So for 3 pi over 2, I end up with -1. And then we need to try f of 7 pi over 6. 7 pi over 6. So I'll do this one. Let's see, that's 2 times sine of 7 pi over 6 minus cosine of 2 times 7 pi over 6. And so the sine of 7 pi over 6, okay, I'll show you how to calculate this one by hand. So 7 pi over 6, that's in the third quadrant, okay. Alright, so here's 7 pi over 6. Alright, well, we need our reference angle, so in this case we'll call the reference angle, we'll do it x with a subscript r. That's going to be xr is going to be 7 pi over 6 minus pi, and that is going to give us pi over 6. Okay, so if you look at this, there's pi over 6. So the sine of pi over 6 is 1/2. Okay, but we're in the third quadrant and sine is negative. So this value here would be -1/2. So we would have 2 times -1/2. And then this would be 7 pi over 3. And you would calculate that just like I did here. Okay, so I'm not going to go over that. You should be able to do it from what I showed you there, that example. So when I plug in 7 pi over 6, I end up with -3/2. And then I have to calculate 11 pi over 6. Okay, so f of 11 pi over 6, that, and it's going to be just like we did this one. So when we plug in the 11 pi over 6, I end up with negative 3/2. And then now we have to do the endpoints. So f of 0, when I plug the 0 in for x, and you're going to calculate it just like we did these up here. So f of 0 is going to give us negative 1, and then f of 2 pi, when we plug that in, that's going to give us negative 1. Okay. So now let's see what we have. Well, this is the largest value that I get. So this one is going to be my max, my absolute max. And then my minimum, well, look at this. I've got here and here. Those two are the smallest. So I've got two absolute minimums. Okay. So I have an absolute maximum at pi over 2. Okay. And now I need the y value. Well, how do we find the y value? Well, you take the x value, you plug it back into the original function. Well, that's exactly what we did here, and we got 3. So our y value is 3, and then our absolute minimum at 7 pi over 6 and 11 pi over 6. So 7 pi over 6, and when we plug the 7 pi over 6 back into the original, we would end up with negative 3/2 and an absolute minimum at 11 pi over 6. And when we plug 11 pi over 6 back into the original function, we get negative 3/2. And so this would be your absolute max and min. Alright, so I hope this video helped. This one was a little bit longer than the other ones, but hopefully it helped. Don't forget to like and subscribe. Alright, thanks.